And welcome to page 7. Here it is. Terminal points for angles that are multiples of pi over 3. And again, this is going to work pretty much like pi over 4 did. You're just dealing with a different kind of an angle. Keep in mind, remember again, if you're going to take pi over 3 and turn it into degrees, which some of you may prefer at this point, so that you can relate it back to something that's a little more easy to understand, you're talking about roughly 60 degrees. Okay, so these are all like 60-degree angles. So if we're going to be dividing into 6 congruent arcs and label them in radians, well, we're kind of going up here, and then here, and here, and the idea, and I know mine don't all look even, but the idea is that they're moving in pi over 3. So this is pi over 3, and 2 pi over 3, and then 3 pi over 3, 4 pi over 3, 5 pi over 3, and then 6 pi over 3. And again, you'll notice that on some of them, we can simply reduce them down, and I'll get a 2 pi over here, and I'll get just the regular pi over there. So, very much like we did before, except we're dividing it up into increments of 60 rather than 45. So, here's what this means. Remember again that the radius of the unit circle is always 1. Remember again, what we're looking for is this little point right here on the where the terminal side hits the angle at a pi over 3 angle, or you could think of it as 60 degrees. And again, we're going to find that by looking at the length of x and the length of y if we look at it as a nice little right triangle. Well, it's no longer 45 degrees right in here anymore. This guy right here is 60. So now we're not dealing with 45, 90s anymore. We are dealing with 30, 60, 90s. And here's the 60 degrees. That would be the one right here at the center. This is your x length. This is your y. And here is the radius, which is always 1. So again, when we do this, I don't have time to go through all of the 30, 60, 90 stuff because you did learn that last year. I will put a couple of links at the end of your link sheet so you can go back and refresh your memory on this. But suffice to say that the side across from the 30 is going to wind up being 1/2, and the side across from the 60 is going root square. Oh, it won't do it for me. I love that. That's really helpful. Let me see if I can go back and make it work. Square root 3 over 2. So my x is going to be 1/2, and my y is square root 3 over 2. And this is when I'm working with a distance of pi over 3, or if you think about it in degrees, it's 60 degrees. So, and again, that's as if I started here at my initial and I went up about pi over 3, that kind of an angle. That's going to wind up putting me at 1/2 comma root 3 over 2 for pi over 3. So again, we kind of want to prove that this actually works. So I'll go through that process real quick. 1/2 squared plus root 3 over 2 squared equals 1. So that's 1 over 4 plus 3 over 4, which again equals 4 over 4, and that is 1. So 1/2 comma root 3 over 2 is indeed a very, very good set of points for on the unit circle. It is indeed on the unit circle. And so then the next thing we're going to do is go back to this idea from the previous video. And the idea was that as you move around and you're moving by pi over 3s, you wind up having the same points all the way around the circle. They just kind of change. The numbers are the same, I should say. The signs will change because, again, as you move around the circle, you're going to be changing where your x's and your y's are positive and negative. So over here, I'm still working with 1/2 and root 3 over 2, but here my x's are negative and my y's are positive. Down here at 4 pi over 3, I should have 1/2 still, root 3 over 2 still, but now since I'm in the third quadrant, they're both going to be negative. And then down here at 5 pi over 3, I'll still be working with the numbers 1/2 and root 3 over 2, except that now the x will be positive and the y will be negative. So as I go around at pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3, I use the same numbers for my x and my y, but I change the signs based on the quadrants where the x's and the y's are positive and negative and so on and so forth. So that's what happens with that. And again, a lot of this is very, very, very similar to what we were doing before. In terms of the 45/45s, we're just working with a 30/60/90 triangle right now. So what's that? Quadrant 1 will be 1/2 root 3 over 2. Quadrant 2 is negative 1/2 positive root 3 over 2. Quadrant 3, they wind up both being negative. And quadrant 4, the 1/2 is negative and the root 3, or the 1/2 is positive and the root 3 over 2 is negative. And again, we skipped 3 pi over 3 because that reduces down to just pi. 6 pi over 3 reduces to 2 pi. And again, we've known what the points are for the last couple of days for these. Pi is -1, 0, and 2 pi is 1, 0. So we've already got points for those, and they don't have anything to do with the 1/2s and -3/2. So keep in mind that when you hit on quadrantals or on something you've already hit and already established, which is what's going to happen on the next page, we go with what we had from before. So again, these are the pi over 3s for this one, and you can see as you're going around the circle where you have the pi over 3s in the different quadrants, because of the 30/60/90 triangle, you wind up with 1/2 comma root 3 over 2, and it just varies, negative or positive, depending on your quadrant.